Hello, good afternoon, everyone, and welcome. My name is Carl Mitroff, and I am the AeroDef Conference Manager. Thank you for joining us today for SME's Technical Community and AeroDef Manufacturing Satellite Session. We appreciate you all taking time out of your day to attend today's webinar. Before we get going into today's technical content, just want to cover a few housekeeping issues. So Google Chrome is our preferred browser for a more reliable experience. So if you experience any technical issues, you might want to try to relaunch your browser with Google Chrome and then joining us that way. You'll recognize that the microphones are automatically muted, and if you have questions regarding webinar functionality, there's a chat feature you can use, and we'll be monitoring that. If you have any technical questions, you can submit to our panel by using the Q&A box that's also available on the platform. And in the event of any technical glitches on your end, please recognize that we are recording this presentation, and we'll make it available a few hours at the end. So thank you for joining us again. And today's webinar is called The Continuous Innovation and Development of the F-35 Program. And in today's webinar, we'll discuss the progress of the ongoing ramp up to the rate production, the continuous improvements in affordability, and leveraging the digital transformation throughout the program. Hosting today's webinar is Don Canard. Dr. Canard is a senior fellow in production operations at the Aeronautics business unit of Lockheed Martin and has been with the company for over 35 years. Don's current interests are digital transformation, advanced manufacturing technology, and manufacturing system design. Prior to this role, Don was production engineer director during the early days of the F-35 program and served in both engineering and manufacturing roles for the F-22 development. And Don has been a senior or an SME member since 2015, so thank you, Don, for that. Joining Don this afternoon is Tara Thomason. Tara is a Lockheed Martin Fellow and a subject matter expert in the area of advanced manufacturing technology and strategy, thermoplastic additive manufacturing, and advanced materials and processing. Thank you both for joining us today.
Great. Thank you very much, Carl, for the introduction. And thank you for Tara for helping with the slides. We had some audio-visual problems getting hooked up today, and Tara saved the day. So first of all, I wanted to just say that Kim Howard was going to do this presentation back when the conference was originally scheduled. And of course, COVID kind of changed everything for us the last few years. I know personally I've been working at home since March. A lot of the rest of us have. We're still building airplanes here. We have a lot of the people coming in to build airplanes. So I'm going to talk about where the F-35 fighter is, where we're going, how far we've come, and give you some insight into how we got where we are and where we're going with it. Next. Now, unfortunately, you're not going to be able to hear the music that goes along with the video. And in fact, I guess the video is kind of stopped, at least on my side. In any case, this video was shot at one of the air shows that we did some time ago. There was originally a lot of concern about the amount of how would I call it, aerodynamics and aero capability of the F-35. I think that's pretty much been put on the side. I would recommend going to see the Paris Air Show videos of the F-35 at the Paris Air Show. It's a heck of a fighter. And again, I think we demonstrated the true capabilities of the airplane in flight. Again, unfortunately, you can't see hear the music, but the video here is pretty cool. And it's obviously somewhere in Florida near we have a some bases down in Florida where we fly the fighters, and there's a big training base down there. And we'll finish up here in just a minute. I don't know. Again, I don't know how well it's coming across to everybody. It's an awful stop and start for me here.
It looks good on our end, Don.
Yeah, just go on, Tara. Next. First, let me talk about Lockheed Martin, the business areas. First of all, we have aeronautics. That's where Tara and I are. We have tactical fighters, strategic airlift, advanced development, and sustainment operations. We have missiles and fire control operations, tactical missiles, maneuver systems and energy, space company, of course, the Orion program, one of the big highlights of that program, satellites. And then we have rotary and mission systems, RMS, which has the Sikorsky helicopter company. Sikorsky people are very proud. They use Sikorsky helicopters, a division of Lockheed Martin. And so Sikorsky is a proud name in helicopter business. But these are our 4 business areas. Next. The Lockheed Aeronautics business area consists of course, the F-35 program, which is one of the largest programs ever in the DoD. 3 different airplanes. We'll talk about those in just a minute. We have the integrated fighter group with the F-2, the F-16, the F-22, and T-50. Most of you might know that we restarted the F-16 line. It closed about, almost 4 years ago here in Fort Worth after delivering 4,500 fighters, and moved to Greenville, South Carolina, and the line is restarted there. And it looks like the business for the F-16 fighter is also excellent. F-22 is obviously a sustainment role, as is the F-2. In terms of Marietta, is producing the C-130s and had completed work on the C-5s. C-130 is going to go over some time. That program's been going on since about 1956, and still a lot of C-130s being built. Now, obviously, they're a lot different today than they were 50 years ago, a lot more advanced avionics and special mission type of aircraft. So, again, a proud history there that goes back a long ways. And finally, I think everyone, we call them advanced development programs. This is really what everyone in the business knows is Skunk Works, who does a lot of our classified developments and prototype work out in Palmdale, California. And again, a tremendous history and legacy of advanced fighter development in Palmdale. Next. For the F-35 in particular, again, we delivered 134 aircraft in last year. We've delivered, as of November, about 585 aircraft delivered. And that's why it's special to me. As on F-22, we built 187 aircraft. And here we are, almost 3 times that number at 585. We have about 335,000 flight hours. We're operating at 26 bases worldwide. We've trained 1,200 pilots and about 10,000 maintainers. We have 8 services around the world have declared IOC, initial operating capability for the airplane. And we have 6 services that have actually used them in operational missions. We've got a total of 13 customers now. And again, as you read the papers, you realize a lot of other nations are looking to operate the F-35. And today, 9 nations have F-35s on their home soil operating from bases in country. Next chart. There are 3 variants of the F-35. We have an A model, which is a conventional takeoff and landing model. That's what most countries are buying. It's the Air Force version of the airplane. We have the F-35B. This is a short takeoff and vertical landing model, really being purchased by the United States, by the UK, and by Italy right now, even though there is more interest in it. And the F-35C, which is a carrier variant, which is for the U.S. Navy specifically, and maybe the Marines too. Big differences here. The avionics systems in all these airplanes are basically the same. That's one of the how would I call it, economies of scale that for the F-35. All the aircraft pretty much have the same software and the same mission systems, avionics in them. They have about 70% of the systems in the airplane are common between the three variants. The vehicle systems, now the structure's not very common. For example, the F-35A is a 9G aircraft. The C and the B are 7.5G aircraft. The F-35C's got a 15% bigger wing. The A model and the C model have 2,000-pound weapons bays. The B has a 1,000-pound weapons bay. So structurally, they're pretty different, even though you'd have to be an expert to really tell the difference between them. Again, when the wings fold on the carrier model, you can really tell. But again, there's a lot of similarities between the aircraft and a lot of common systems on the airplane. Next chart. One of the features of the F-35 is not only its stealthy capability that everybody's pretty familiar with and weapons capacity, but it's the sensors on the aircraft, the EOTs and the DAS and the helmet that gives the pilot tremendous visibility. The sensors are fused together with our fusion software and network-enabled operations, electronic warfare systems. But again, it's the 360 degrees coverage of all the sensors around the airplane and the way that information is fed into the pilot. I mean, there's even a mode that obviously those of you who know the jet, where you basically can look through the airplane, the invisible jet to the ground, and look through the radar systems at the ground, even through the airplane. So again, a lot of sophistication in the helmet, a lot of work went into fusing data for the pilot. It is kind of the perfect edge device where it takes all this data and provides the pilot just what they need to run the mission. So again, the sensors is one of the biggest aspects of this. Again, it is a 1.6 Mach aircraft and an excellent maneuverability. Next chart. Production ramp. So here you get a little bit of a history starting back in 2011 with the first production aircraft. We ramped up and stayed at about 30 aircraft for a while we were doing all of the SDG testing, all the static aircraft testing, the fatigue testing. We started ramping up really in about 2017, went from 66 to 91, had 134 aircraft delivered last year, and we were planning this year to be over 140 aircraft, and of course, COVID had something to say about that. So we're going to be in the mid-20s, mid-120s probably for the year. I don't know the exact number there. But again, we're working real hard with our supply chain. The issue has really been the supply chain. A lot of our suppliers, remember, we're an international program. We buy parts from all over the world, from Italy, from Israel, from all over Europe and Japan for this airplane. And so the international feel for the airplane, international involvement of the airplane has really driven some of the supply chain issues. But again, we're working with them. Lockheed funded a lot of our suppliers to stay in business while they could continue to make parts for us. And so we're slowly recovering and ought to be recovering sometime towards the end of next year with the deliveries. Again, lots of capacity for future orders. We're starting to fill those wells out in front of us. But we're essentially at rate production right now, or will be very quickly. Next chart. Well, as we've increased the production rate, obviously we've been decreasing costs. We've been working on cost and affordability for the F-35. That was really the hallmark of the program. How do we make the aircraft affordable? How do we make 3 versions on a single assembly line? And some of the features of the airplane make that possible. We've had shared learning between all the variants, meaning that even though the A, B, and C are different, they still have the same materials, processes, fasteners, all kinds of the requirements of the airplane are the same. And so we've actually shared learning on the learning curve for each of those individual aircraft. And especially the Bs and Cs have really benefited from us building the A models, which are 70% of the aircraft, or A models. The B models and the C models are about 15% each, but they have benefited from the large volume of A model aircraft. Again, assembly-wise, a lot of similarities in parts, a lot of similarities in testing. Next chart. as we've increased the production rate starting back in LRIP 1, we've reduced the cost by about 70% as the production rate's gone from 32 aircraft a year to about 140 aircraft a year. Uh, I think I'll point out our mechanics are, we hire mechanics and then we teach them how to be F-35 mechanics. One of the big things we did on the F-35 is we set up a very rigorous training program where we have components that the mechanics work on in training that resemble the aircraft and the configurations. In fact, we have a weapons bay with very complex harness installations for the weapons bays. We have finishes of the airplane, of course, very complicated finishes on this aircraft, and we have the mechanics work with realistic components to learn how to apply all the coatings and finishes to the airplane. And in fact, even in our weapons bay harness installation component, we even use augmented reality to help teach the mechanics about building the airplane. And in fact, we have our first deployment of augmented reality in production on the F-35 with wire harness installations for the wing. Next chart. What has facilitated our cost reduction, affordability opportunities is really the digital thread. People talk about model-based engineering like it's something new in the business. Well, we've been doing model-based engineering along with a lot of other people for 20 years. I mean, we release solid models to the suppliers. We use solid models for integrating between our partners. Our partners obviously are Northrop Grumman, BAE. We're the major partners, Pratt & Whitney for the engines. And all of the models were coordinated. All the integration was done through the models. We send solid models, for example, from metal parts directly to the suppliers. They inspect to those 3D solid models. They NC program the machining to those 3D solid models. We did simulations. So the digital thread is really the creation, use, and reuse of the model-based data from engineering to manufacturing to sustainment. And all those models end up, in fact, in the sustainment tech order. So a lot of visual quality to it. We have obviously 3D visualization software to be used for work instructions, and also did a lot of inspections using laser trackers and NC programming. Now, automation, if we go to the next chart, automation, like automated drilling, was enabled by the digital thread. For example, the engineering information had the vectors for the holes and the material stacks, and we used that to program the automated drilling. We automatically drill about 20% of the holes on the airplane, but we continue to add more capability to drill holes as we mature and bring in more equipment and get to the higher rates. Most of the equipment has been these gantries, but we're starting to now bring in some actual robot drilling. I know Northrop Grumman used robotic drilling originally in their inlet ducts and other places, and we started now bringing them in to use them for harder to reach spots. Now these automated drilling machines drill, ream, and countersink in one step. It's a stacked drilling operation, and in the near term, we're actually going to start measuring the grips as we drill the hole so we can hit the fasteners more efficiently. Next chart. The other part of automation, and not unexpectedly, is robotic coatings. All of the coatings on the aircraft are applied using robots. Robots control the amount of material that gets on the airplane, highly repeatable. Obviously, we want to put enough coating everywhere, but not too much. And so this is one of those ways that we're trying to utilize the coatings or the robots to apply highly accurate materials on the airplane, and has been a big success. Next chart. And the third application of, again, the digital thread, this one is taking the 3D work instructions, the 3D data, and putting it into the hands of the mechanics. Several examples of that. This one here is we're using optical projection. So we're projecting into the inlet duct, in this case in Marietta, Georgia, a pattern of what fasteners go in what holes to make it easier for the mechanics. Otherwise, the mechanics would have to look at drawings. Other ways of doing this same type of thing might be augmented reality, but we have found optical projection to be a very efficient way of providing that information to mechanics. And there's a lot of different kinds of fasteners in here. You not only have different grip lengths of fasteners, different sizes, but you also have Inconel fasteners versus titanium fasteners. So all of those things, this equipment helps relieve the mechanic of having to look through a bunch of drawing pages and writing on the skins which fastener goes in what hole. So this is one way we found to consume the engineering in a way to benefit the mechanics. Other examples of that include additive manufacturing. We have made thousands and thousands of tools, temporary tools, partial tools for the mechanics to use on the floor, masking agents, all sorts of different developments or different applications for plastic tools. We have quite a few machines here cranking out these tools. Next chart. So that gives you a little bit of perspective of where we've been. We utilize the digital thread in production to prepare cost. We have a lot of robot systems coming in, about 70 different robotic systems, some of them duplicates coming in over the next 2 years. So a lot of activity still on affordability for F-35. One of the great things about F-35 compared to F-16, or excuse me, F-22, is the fact that I have a long production forecast, which allows us to continually invest in development of the aircraft, continually invest in the improvement of cost and affordability. And so that's a big benefit for a long-term program like this. And a lot of the technologies we develop for manufacturing also apply to sustainment. So sustaining the aircraft, things like augmented reality will benefit sustainment, things like some of the drilling technologies we've had, additive manufacturing, a lot of opportunities to benefit sustainment as well as manufacturing as we do this. Industry 4.0 is another focus for us. That's the next industrial revolution. That's the integration and the revolution of data and taking data from the floor, connecting with our equipment with IoT technology, taking data from the floor and using it to reduce costs later in production, all of those kinds of things, as well as, in fact, generating automated reporting and using data analytics and AI to do analysis. That's really one of our key focuses for the future. Next chart. Now let's talk a little bit about sustainment here. We're talking about delivering the readiness for sustainment. Next chart. This has been a big focus for us. First of all, let's talk about bases. As I mentioned before, I think there's right now supposed to be about 26 bases stood up. This is the 2016 to 2022 stand-up. There'll be 30 bases towards the end of 2022, and you kind of see them here. These are very obviously complicated installations. We have a lot of training to do. Maintainers have to be trained. Pilots have to be trained. And then we have to supply all of these bases with provision for all the parts and spares and all kinds of equipment. So again, this is a heck of an operation on the F-35. And the more and more countries that join the program, obviously it makes this even more interesting. But again, this is going very well. I mentioned that 9 countries already have them aircraft in country. So this is going down. Next chart. And again, our goal here is to deliver more readiness at less cost. Obviously, our mission capable rates are improving lot over lot, and we've reduced the cost per flight hour in the latest contract by about 10%. So we're increasing supplier availability. Again, that's been a little bit of an issue I mentioned in the COVID environment with some of our suppliers. And again, we're continuing to work on our ALICE system and Odin system. Those are our sustainment systems, as well as the integration with our enterprise IT system. So again, continuing to work on mission capable rates, continuing to work on the cost per flight hour. Next chart. Modernization. When you have an airplane, whether it's F-22 or F-16 or F-35, you're continuing looking to modernize it to outpace the ongoing threats. Next chart. So one of the things we're doing is adding more missions to our multi-role fighter already. we already are mission for strategic attack and close air support and SEADID, air superiority, and extending it now to extended surface warfare with all of our ops and communications capabilities of the airplane. So we're continuing to add missions. And next chart. And we're essentially widening the gap over fourth gen aircraft. I mean, the F-22 and the F-35 are the only fifth generation aircraft. We've added auto GCAS is being integrated. Those of you who we got the Collier trophy a couple years ago for auto GCAS, this is the program that keeps pilots, that protects pilots from running aground, so to speak. We have open systems architecture coming on board in the Tech Refresh 3, TR3. Obviously, multi-domain operations that are continuing to get improved. Unmanned teaming with drones, for example, is something we're working on. Missile defense, of course, extending the range of the airplane, and of course, a lot of classified opportunities. So again, continuing to add capabilities to the aircraft as time goes on. Really in blocks. So I think we started with block 3. We're putting in block 4 right now, but there's plans for block 5, block 6. Again, the capabilities get added as the technology improves, and it's just a continuous improvement of the airplane. Same thing with weapons. We're increasing the capability, internal weapons capability, integrating new weapons into the airplane, including some from different countries. That's kind of part of our business model is some countries want some of their own things. So that's also things we're working on. But again, increasing the capacity for the weapons as well as the different types of weapons that go in there. Next chart. Finally, fifth generation performance at a fourth generation cost. We achieved our goal of getting less than $80 million per copy for a conventional takeoff and landing aircraft. Mission capable rates are getting to 80% that we wanted. We're going to be at $25,000 per flight hour by 2025. And again, a generational leap in capability, specifically because of all the avionics and advanced sensors and sensor fusion and the fusion with the helmet and the pilot on the airplane. So this is one of our kind of get off the stage chart. And Tara, one more, and we'll have a little bit. Hopefully the video will play here well, even though you can't hear the music. And Tara, if it's too jumpy, we can just go through it. Over 3,000 jets are planned overall for the airplane. We've built, again, 585 so far. Now it's actually 26 bases now. And 335,000 flying hours. Again, I mentioned 1,200 pilots trained now. Again, this was for the AeroDef last year, and about 10,000 trainers trained maintainers. Service is declaring IOC, initial operating capability, continues to improve. 9 countries in country flying, and reduction in costs for the airplane. By the way, these $80 million is pretty comparable for some of the fourth gen fighters out there. So very focused on sustaining these aircraft in the field and making sure that the customer gets their money's worth from the aircraft with availability. Huge supplier base all around the globe, thousands and thousands of jobs in lots of different countries, a lot of advanced technology. This is a heck of a program. And by the way, I'll recommend you go to f35.com. There's always cool videos and stuff on there. And that may have been the last chart, Tara. Is there one more for questions, maybe? Great. In any case, I wanted to just wrap up by saying that I've been on the F-35 program. I came on about 2004 timeframe. I worked on it a little bit before, but I came on in 2004 as we were really starting to get the first production aircraft really designed and out. The factory here has got over 200 aircraft working at any one time in the factory here. We're cranking them out. Today, of course, you go out there and it's a sea of safety glasses and COVID masks. The mechanics are probably and if you've ever worn a mask and wore sunglasses or glasses, you understand how difficult it is. But that's something what we're going through. But the people that are coming into work, the people that are coming in to build the aircraft, again, we have been able, even with our supply chain, to continue to build aircraft here, and look forward to getting back to whatever the new normal is going to be sometime towards the end of next year. So now I'd be happy to take any questions that you might have.
Hey, Don, we've had a handful of them come in through the Q&A app, so please continue to send them in if you have any questions. I think I'll start out with the hardest one you're probably going to get from Mr. Daniel Clark. Currently, missiles and fighter jets fight against something called gravity, similar to swimming upstream of a river. Do you have any plans to quantum trap the magnetic field to overcome the gravity limitations that limit hypersonic travel?
Not for the F-35, that's for sure. The F-35 is not a hypersonic vehicle, although some of the weapons may be hypersonic vehicles. And I'm not exactly sure to answer the question about the gravity effect, so I'm going to pass on that one.
Okay. Sorry, Daniel. I had a feeling he wasn't going to be able to answer that question. All right. Next one is from Matt Sheridan. How will the work scope being resourced from Turkey be divided among the U.S. and foreign suppliers?
Well, the major work in Turkey, and I got to tell you that we've been working with Turkey on F-16 and F-35 for a long time. They're fantastic producers, and so it's a real shame that, the politics, the way they are, kind of led us away. But Northrop Grumman, for the most part, is going to pick up center fuselage production from Turkey, and we're continue to outsource parts as time goes on from Turkey, metal parts in particular. They were doing a lot of composite parts for us for Northrop Grumman. So we're going to continue to outsource those parts. They're luckily, I guess, as more partners are coming on for the F-35, all want to do a little bit of the business. So far, and by the way, because of some of the issues with commercial build supply chains, we've had a not too tough time finding people to build the parts that we need for the airplane. Because again, our business has been staying steady. Commercial business has gone way down, as you probably know. So a lot of hungry suppliers out there. So that's kind of how we've been working that. But yeah, again, it's a real shame that Turkey isn't a partner anymore, but that's the nature of the beast.
Okay. Our next question is, how much of the target production cost is machining related?
Oh gosh, and this is a rough number, but a lot of the airframe parts are, kind of a 15% number of the airplane. The airframe parts, mean the composites and metal parts. I don't know how to break that down for just machining, but there is an awful lot of machine parts on the airplane. We have, gosh, I don't even know the exact number of them, and they're all obviously very large parts. We tried to make them large in order to save weight. So, but we do an awful lot of NC machining on the parts, and that's at all of our suppliers.
Okay. And I'm going to change up this question a little bit. So out of all that machining, Don, that we do, about how much of the aircraft's composite versus machine metal?
Okay, well, the aircraft is about a third composite, a third aluminum, and a third titanium, and with differences in the variants. For example, the carrier model with a bigger wing has more titanium than the B model. The B model has a lot more aluminum percentage-wise. It's pretty much composite in the surfaces of the airplane. That's an interesting thing, I started in business as a composites engineer, and I think over the years we realized is that composites have their place, uh, but it's in areas where it's in tension, compression, loading, like in skins of the airplane, as opposed to substructure. So for the most part, affordability drove F-35. We used composites on the surface of the aircraft, loaded in the ideal tension, compression, loading, because that's the place where the composites saved enough weight to justify their use. And everything is decided by a cost per pound type of number. So that's kind of how we do everything. And so again, some places composites work well, and some places they're not as efficient as titanium or aluminum. And so those are the trades that we make.
How much of the cost reduction that we've had would we attribute to the learning curve versus new technology investment?
Well, typically, if you look at the overall learning curve, it's typically about 25% is learning, and 75% is doing one of a few things. 75% is improving the supply chain, improving quality on the airplane, doing changes, affordability changes. So that's kind of a typical split is 25% pure learning by the mechanics and 75% being improving the supply chain, improving the design of the airplane, the planning, the tooling, and all of that kind
Okay. This one's near and dear to my heart. Are there any additive parts being used on the aircraft?
of. There are a few tiny little additive parts made out of plastic on the aircraft, and again, as I mentioned, we've made thousands and thousands of tools and shop aids for the airplane. Now, you might ask, well, why is that? Well, the fact is that additive manufacturing, in terms of being used for fracture critical parts, is quite a long ways to go. We continue to work. We've built some what was a big horizontal spars for the F-35. But issues for additive manufacturing are several-fold. One is inspectability, and cost is an issue too. Fact is that additive manufacturing, at least in my opinion, doesn't compete favorably with subtractive machining on a part-to-part basis. So I believe that additive manufacturing is kind of here for parts that could be made different ways. Things like big weldments, heat exchangers, and things like that. And it's a while before I think we'll see them in any sort of structural, bulkhead frame types of applications.
And I agree with you. Matt Savage, who is in Dayton, Ohio, wanted to understand what kind of effects has COVID had on our production?
As I mentioned a couple of times through the presentation, the supply chain was significantly impacted by COVID. We ourselves have not been very impacted by COVID inside the plant. We have had cases of people that have gotten COVID outside and brought it in. We've had a few of those kinds of things, but our own workforce hasn't been dramatically impacted. However, we had several of our suppliers in Italy, in Israel, in California that literally shut down for a month or 6 weeks, and it's been an on and off kind of thing. With one good example, we have to fly to Japan in order to fly the aircraft for the first couple flights, and the government pilots have to fly there to fly them for the acceptance flights. Same thing with our plant in Italy. So getting people to Italy and Japan has been very difficult. And right now, I think we're still quarantining for 2 weeks many times when we go. So it's made our delivery process in foreign countries very difficult, and it's impacted our supply chain fairly significantly. As I mentioned earlier, Lockheed took on the initiative with some of our smaller suppliers to actually give them advanced payments to keep them in business. We have to have these suppliers in our business. We depend on our suppliers. 70% of the aircraft is from the supply chain. So again, I think we were very aggressive in supporting our supply chain during COVID and looking forward to it getting over this next wave that's going on now. And there's a possibility we could be impacted more going forward, at least in the near term, until the the vaccine is enough out there to protect most everyone. I know personally, I'm looking forward to going on vacation again.
I think we all are. A question on the base stand-up map that you had in your presentation. What was the difference between the blue and yellow dots? What did they signify?
That's a good question. They have successfully stumped the chump here because I do not know the answer to that question.
Is there any plans for remote piloted capabilities in the F-35?
Well, I think I even showed a picture of the fact of drones being controlled by an F-35. That's certainly some of it, and just like every airplane, I think I've worked on, there's always plans for remotely piloting vehicles. I don't know whether F-35 will ever get there or not, but certainly we will have drones or other aircraft, the smaller aircraft perhaps, that will be controlled by F-35 and be flying alongside. So those are things that I think everybody's working on out there.
And then we have an IoT question. Have we integrated overall equipment effectiveness, or OEE, in our manufacturing plans for these programs?
We have been very aggressive about connecting our equipment to the intranet. For example, we are connecting equipment. We are looking at utilization. I don't know that Tara, you may know, I don't know that I've seen OEE specifically, but we are looking for preventive maintenance. We are looking at utilization. And I want to tell you, my vision of IoT is not monitoring equipment. My interest in IoT is in connecting the engineering and the manufacturing together to be able to, for example, automatically inspect the as built to the as designed in the model-based engineering, to be able to measure fasteners while we drill them, send that data to get those fasteners fitted and delivered back to the floor. So I see IoT, the connections, as enablers to be more efficient and to do things like as designed, as built comparison. And there's so many different examples of that kind of engagement between the data. As I mentioned, Industry 4.0 is the revolution of data. It's not just data it's not just models, but it's also data for traceability all the way from engineering through sustainment and how all the systems tie together. It's automated reporting. I mean, a lot of people make charts, and we're going to try to put the chart making out of business and automate a lot of those reportings because nobody really likes to do that kind of thing anyway.
And then let's see, what type of structural health monitoring systems are integrated in the body and propulsion system?
We do have and continue to improve on a prognostics health management system for the airplane. We have, it's one of the continuing developments. Obviously, we have sensors on the airplane that measure stresses on a real-time basis. We have, I believe there's corrosion detection equipment on the aircraft. Those are all things that we continue to put in. We have some in now and continue to add those as we go forward. Again, the idea being to know what the aircraft is going through. We follow each and every individual aircraft. We know what kinds of loads each individual aircraft is, what kind of missions they've flown, and do that for life management and predictive health management.
All right, is there an advised path for becoming a vendor or supplier for the F-35 program?
Well, I think we're always looking for new suppliers, and really we're available online. You can get a hold of us and through the internet. Our supply chain people work with them, but obviously we have a lot of requirements to be a supplier for Lockheed Martin. You got to be ISO certified and all that type of thing. But frankly, we're always looking for new suppliers who have special technologies or affordable. There's really no limit to that. And by the way, it's not just for F-35, but a lot of new programs. out in Palmdale, for example. So there's opportunities, lots of opportunities with Lockheed Martin in terms of making parts.
And I think the last question I see is, with projected added capabilities, are there any planned changes to EOTs or potentially missile warning systems that you're aware of?
Well, there's all kinds of things coming. And, it's not, a lot of it is not things I can talk about, but there's a lot of advancements coming for F-35. And it's the nature of the beast. We have a platform, but technology moves on, and we need to continue to harness the new technology coming in for advanced capabilities. And that's something that'll go on over the life of the aircraft for the next 50 years. So that's one of the funnest aspects of the aircraft is, F-16 is a perfect example. We've been making them for 40 years. There's been at least 6 major blocks for the F-16 that have added capability for the aircraft. And you see the same type of future for an F-35. I don't know. I mean, I think, I think you've seen it. Maybe there's lasers on the aircraft at some point. I mean, that's actually been in the press, but all kinds of cool stuff.
And I don't know this acronym, Don. I don't know if you will. How is HWIL and SIL testing facilitated and improved the systems development for the aircraft?
Well, the Systems Integration Laboratories, I think, is what they're referring to.
And there you go. Thank you.
Yeah, we have where your husband works, I think.
Yeah.
We have.
Yeah. Don't. No one tell him I didn't know what it meant, please.
But we have extensive facilities here for software development, both vehicle system software and mission system software. And that's the kind of the key feature for going forward is to be able to do that development in those laboratories, develop the software. People don't appreciate it very much, but we are a software-heavy airplane. And in fact, we have a lot more software people and electrical engineering people than we have structures people on the airplane. That is our number one product is lines of code for the airplane. There's, probably 5 or 6 times maybe the amount of code in an F-35 than any aircraft that we've ever built before. So we have extensive laboratory facilities for doing that kind of work. I think the future, though, is we want to be able to better automate software development, to be able to do, now that we've built the airplane, we've got a lot of models, we have what you would call a digital twins for a lot of systems. So we're much better able to integrate new capabilities because we have all the models that have been proven out and tested and validated. So true digital twins being something where I have a physical aircraft as well as a model for it. So again, I see that as accelerating our ability to put new capabilities.
And we got one more question that just came in. We're making inroads with Lockheed's supplier, F-35 suppliers, on automated solutions for composite parts manufacturing. What's the best route to engage on that type of development through OEM supply chain adoption of the technology?
Well, again, automation. I think in fact, some of us spent quite a bit of this week with our Danish partners and looking at all kinds of robotics applications, and composites was one of those things. So I want to say, if you have a good technology and good ideas and can compete affordably with our current suppliers, let's. And by the way, it's not just Lockheed Martin, but obviously Northrop Grumman's a big partner, British Aerospace or BAE, all partners in this business, and all of us are always looking for ways to improve costs. So we're not hard to find. We're the biggest program on the world. And our supply chain, Lockheed Martin, you can get a hold of us, find us easily, and get a hold of our specific buyers in different areas. So that's where you would start, is with our purchasing group, supplier group.
And then Bob Heyer has asked, when is Block 4 projected to have their IOC?
Oh, Bob, it's so good to hear. I'm so glad you listened in. I wish I could to talk to you. Bob's one of my old buddies who was one of our customers, JPO customers, for years and years and years. One of my favorite people in the business, as a matter of fact. And I'll just say, TR3 is, I think, lot 15, Bob, which is, I think, probably in the 2022 timeframe, late 21, 22. I'm not 100% sure of that, but I know that it's, I think, a lot 15 type of thing, and it's coming on. We're doing all the development now, all of the systems development for TR3. And as I mentioned, it's also going to have some open system architecture, those of you familiar with that.
And then does Northrop do any machining on their part of the aircraft?
Yeah. Now, for the most part, and I would say a lot of us these days, we do some internal machining, but Lockheed Martin and Northrop Grumman do a lot of their machining in supply houses. BAE does a lot of their machining in-house, especially titanium, because the aft fuselage has a lot of titanium, so they do a lot of their machining in-house. But Northrop Grumman and Lockheed Martin, we do, I would say, a majority of our machining with outside suppliers. So.
All right. That seems to be it for the questions. Carl, go ahead, Don, please.
Well, I just wanted to thank Tara. Thank you very much for your help and the questions, and for the audiovisual help you gave us earlier in the conference when my computer wouldn't work like I wanted it to. And let's turn it back over to Carl for a brief commercial.
Brief commercial. No, thank you. Thank you very much. Very informative information on the F-35 program. So thank you for sharing. And thanks so much to our hosts, both Don and Tara, for taking time. We appreciate you supporting SME and our events and also the manufacturing community. So special thanks for that. And also special thank you to all of our attendees who participated today. Please note that we're going to be distributing a quick webinar survey at the end of today's webinar. So we would appreciate your time providing us feedback so we can continue to improve what we deliver. And then one more time, this recording or this webinar will be recorded, has been recorded, and it's going to be available on the AeroDef website in a matter of hours. So give us some time to package it together to get it on our site. So it will be on demand shortly. And then also be sure to join us next year as we begin to develop our content for 2021. In January, we have a webinar series will continue with thermoplastics manufacturing technologies for aerospace applications. And that's going to be hosted by Nick Malello. He's a technical director from the Advanced Technology International, or ATI. And look for that on our website. Registration should be live, if not right now, in a matter of hours. So always continue to follow up and go to our website, the AeroDef website, for more content and more information regarding the satellite series as well as the AeroDef conference. And to everyone, again, thank you for your time. Have a great Thanksgiving and a happy holiday season, and we will see you all next year. Thank you and goodbye.
Bye now.